So addition theorem of probability. Let A and B are any two events associated with a random experiment of sample space S, then probability of A union B. So the verbal form is at least one of the event occur. That is probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. So in set notation, that is in Venn diagram. So the union of A union B region is the entire this. So in set notation, you have a formula n of A union B. That is number of elements of A union B is written as n of A plus n of B minus n of A intersection B. This even you can observe from the Venn diagram directly. That is entire union of these elements will be n of A plus n of B, because you are adding this two times, you have to subtract it one time. So probability of A union B as per the definition n of A union B upon n of S. So replace the formula n of A union B and separate the terms. Now, suppose if A and B are mutually exclusive events, that is their intersection will be a null set. So n of A intersection will become 0. So probability of A union B will become now probability of A plus probability of B. So whenever you have mutually exclusive events, the probability of their union will be sum of the probabilities. And this can be extended. Yeah. So not only for two sets A and B, even this can be written for three sets also. Sir, I want the second step. So probability of A union B union C. So group B union C and apply the previous one. So probability of A plus probability of B union C minus probability of A inter B union C. Now again probability of B union C will be same as probability of B plus probability of C minus probability of B intersection C. Now here you need to apply distributive property, that is A intersection B union A intersection C. Now again for this A intersection B is one event, A intersection C another event, apply the same property again. So probability of A plus probability of B plus probability of C minus probability of B intersection C minus probability of A intersection B minus probability of A intersection C plus probability of A intersection B intersection A intersection C. But this will be same as A intersection B intersection C. So when you are having three events, that is union of three events. So one at a time, all will be plus. Two at a time, all will be minus. Next, three at a time will be plus.
So probability of A1 union, A2 union, A3 union, A4. So this can be written using the previous formula as an extension directly. That is 1 at a time, 2 at a time, and 3 at a time, and 4 at a time. Now extension of this, that is inclusion exclusion principle. That is A1, A2, A3 and so on, AN are n events of the sample space S. Then probability of A1 union, A2 union and so on union AN equal to, in simple form, probability of union I equal to 1 to n, AI can write. So this will be equal to sigma I equal to 1 to n P of AI minus sigma I less than j and I comma j from 1 to n probability of AI intersection AJ plus sigma I less than j less than k 1 to n probability of AI intersection AJ intersection AK minus and so on. The last term will be minus 1 to the power of n minus 1 probability of A1 intersection A2 intersection and so on intersection AN.
So if A comma B and C are mutually exclusive events, then probability of A union B union C equal to sum of the respective probability. That is probability of A plus probability of B plus probability of C. Next, probability of A intersection B bar will be same as probability of A minus probability of A intersection B. That A intersection B bar means occurrence of only A. So from the Venn diagram, outside of B intersecting with A, that is probability of A minus probability of A intersection B. In the same manner, probability of A bar intersection B written as probability of B minus probability of A intersection B. Next, probability of A delta B, that is symmetric difference. So one definition is A union B minus A intersection B. Another one is A intersection B bar union A bar intersection B. Now, again, these two events are mutually exclusive events. So the union of this will be sum of the probabilities. So probability of A plus probability of B minus 2 times probability of A intersection B. Also same as probability of A union B minus probability of A intersection B. Next, A intersection B is a subset of A. So probability of A intersection B will be less than or equal to probability of A. A intersection B is also subset of A union B. So probability of A union B less than or equal to probability of A union B. Next, probability of A union B also can be written as less than or equal to probability of A plus probability of B. So A comma B and C are events of sample space S, then probability of only A occur. So in set notation is probability of A intersection B complement intersection C complement. So using the Venn diagram, you can write the formula directly. So probability of A minus probability of A intersection B minus probability of A intersection C plus probability of A intersection B intersection C. This is a region only A. Next, probability of A and B occur but not C. That is outside of C intersecting with A and B. So this is a region. And this region in terms of probability can write as probability of A intersection B minus probability of A intersection B intersection C. Next, probability of only one event occur means it can be occur only A or only B or only C. So using the first one, you can write this formula easily. That is probability of A plus probability of B plus probability of C minus 2 times probability of A intersection B minus 2 times probability of B intersection C minus 2 times probability of C intersection A plus 3 times probability of A intersection B intersection C. Next, probability of only two events occur means A and B occur but not C, A and C occur but not B, B and C occur but not A. So using the second formula, you can write directly as probability of A intersection B plus probability of B intersection C plus probability of C intersection A minus 3 times probability of A intersection B intersection